Okay, so going back to our work from the start of the year where we are looking at the solution of simultaneous equations of something like y equals x squared plus 2x plus 4 and the line y equals 4x plus 7. Now we know that it's going to look like a curve and a line intersecting it. In fact, if I want to have a look at what the solution is using a website called Desmos, we can see exactly what the coordinates are because it will do all that work for you. The way that we were looking at solving these, however, was we were looking at saying that we'd have two graphs equal to each other. So the sort of thing I would do would be something like x squared. What have I done there? Cancel. X squared plus 2x plus 4 would be equal to this graph here, this one. So what I do then is then just put that equal to 4x plus 7. So then I'll just get it all onto one side and make it into a quadratic. So in our case here, it'd be x squared. In fact, actually, it wouldn't be plus anything anymore because 2x take away 4x is minus 2x. And then plus 4 take away 7 would be minus 3 is equal to 0. Now what that would do is it would factorise to x minus 3 and x plus 1. And that would then be equal to 0. So I know now that x is equal to 3 and x is equal to minus 1. So what we were doing from there was we were subbing those into either this one here or this one here to find out what the y coordinates are. So let's do that for example. When x is 3, sub in here, 4 times 3 is 12, add the 7 is 19. So that's how we got that 319 over there. And when we sub in minus 1, 4 times minus 1 would be minus 4, add the 7 would be positive 3, so there you go, you've got minus 1, 3. Now if we went and actually had a look at that graph there, what we've got is something like that, where it's just basically we've gone and found what its roots are. So that graph there had the other graphs subbed into it, and it's telling me what just the x coordinates are, and that's how I then go and find my y coordinates. Okay, so just a little bit of history into what we've been doing so far. So bringing that idea from what we were looking at from before into this here, we've got, I know you know how to do all this stuff, I'm not worried about that. This is the bit we're struggling with. Given that the equation x cubed minus 6x plus 20 is equal to k, so that it had, was it one real root? I think I've messed this up a little bit actually if I try and move that. There we go. Has 3 distinct real roots. Find the possible values for k. Now what I was doing before was saying, right, that graph's moving up or down so we always get 3 real roots, but there's a quicker way to do it. And the quicker way to do it is say, where can I draw a line so that I always get 3 real roots? Well, if I draw it up here, if I just extend this graph up here, and this one going down to here, then if I go here, I'm just getting one real root the whole time, and then eventually as I start getting exactly at the 27, I've got 2 real roots, but as soon as I come less than 27 here, I'm now getting 3 real roots, 1, 2, and a third here. 3 real roots, 3 real roots, 3 real roots, 3 real roots here, 3 real roots here, 3 real roots, until I get to this point here, I'm back to 2 real roots exactly at a line of y equals minus 5. So I want to have numbers that are, for 3 real roots that is, this is the key bit here, that are less than 27, because we look at the y coordinate, but I want numbers as well that are greater than minus 5. So my answer is k must be less than 27, but k must also be greater than minus 5. So what I can write is that in one continuous loop, which if I swap the sides of k here, I can say minus 5 is less than k. So then this thing here, I can match up over here, and then bring minus 5 is less than k there to get my solution. Okay? This question here is Jan 2008, question 10. This one's pretty much the same thing, but there's one tiny difference. This time it says only one real root. So I'm thinking, where can I go and draw lines going straight across until I only get one real root? And it's all of these ones up here, isn't it? Above the stationary point, all of these, until here, at this point, I'm now getting 2 real roots. In fact, here now 3, 3, 3, 3, 3, 3, 3. Then back to 2 at this line here, and then back to 1 when I'm just drawing lines straight across here. So this one's a little bit different, that I'm only interested in values above this point here and below this point here. So I just get two separate inequalities. Here I'm interested in k is greater than 20, and then in this point here I'm interested in k is less than minus 12. Now, as far as I'm aware, we cannot write that as one consistent inequality like before, because they're two separate things. I'm only interested in either up here or down here, whereas the one that we had before, I was interested in values between these 2 points. That's not the case this time. It's not like the two arrows are pointing each other like last time. Okay then, so having a go at this one, pause the video and have a go. Again, I've done the hard work for you here, so let's say we've done all this bit, this part A and this part B, we've got those 8 marks. What about getting that equals k here? Now the key words, I'm not going to underline anything yet, I'm just pointing out that thing there. Pause the video, have a go, see if you can work out what the correct answer is to that. Okay, so the key word here was one real root. So where can I draw lines through, straight lines, so that I only get one real root? And all of these ones here that I'm drawing with the laser now, they're all one real root until I get to this point here. Now that's 2 real roots, and this is now 3. All of these are 3, 3, 3, 3, 3, 3, back to 2, and then here just 1. Okay, so I'm interested in values above here. So k must be greater than 19, and I'm interested in values below this point here, or maybe just above that point there. Try and redraw it. Let me try again. There you go, like that roughly. And these ones below here, so k must be less than minus 13. Can I write that as one continuous inequality? No, because they're two separate areas. I'm interested in this area up here or this area up here. So those ones there are my final answers. Okay, so k greater than 19 and k is less than 13.